All right, I hope you all are having a wonderful Monday. So we're going to talk about inscribed angles today. So we talked a lot about central angles, and central angles are angles who have the vertex at the center of a circle. Inscribed angles are angle whose vertex is on the circle. So this part right here is the vertex and it's on the circle. And then it extends out to two other points on the circle. Okay? And an intercepted arc then is the section of the circumference bounded by the two ends of the inscribed angle. So these are the ends of the inscribed angle, and this is the vertex that's on the circle. So that's what makes it an inscribed angle. Okay? So there are some special properties about inscribed angles and intercepted arcs. So the inscribed angle says the measure of an inscribed angle is half the measure of its intercepted arc. Okay, so if we say that this right here, the measure of AB is 110. So from here to here is 110. That makes this inscribed angle 55, half of that, okay? So they're just half. It's all you're doing is half or doubling. Okay, so then if xzy is 62, that means that the measure of xy then is 124 degrees, because that is double the inscribed angle, because this is the intercepted arc. Okay? So then we can use that to find missing parts and pieces here. So the first thing is I'm going to find these inscribed angles x and y, and so I know that x is half of whatever this is here, because this is the intercepted arc. So this is the point. I like to put points on the three that I'm referring to. So there's the vertex and the two endpoints of that. So we have 70 plus 80, and we want to take half of that. So x is equal to 75 degrees. Okay, then I can take 360 degrees and say, oh, I know that this whole thing needs to be 360 degrees, and I can find the measure of this piece, FG. The measure of FG right there is going to be 360 minus all those other pieces. So 70 plus 80 plus 90. Okay, and that's going to give me 120 degrees. So now I can use that to figure out what y is. And I'm noticing on the notes that I uploaded that is incorrect. So y has an endpoint here and here. So that is y equals 1/2 of whatever 120 plus 70. So again, that's incorrect on the notes, just so you know. And so 120 plus 70 is 190. Okay, and so half of 190 is 95. So we know that y is 95 degrees. Okay, we can also use that on triangles that are drawn inside or inscribed in circles. Okay, so this is a triangle that is inscribed in a circle. So the first thing is I can look at this and say, oh, I know that this piece right here is 64, because it's a double 32. So we double this angle here. So remember, these are the endpoints of that angle. So it's what's in between is 64 degrees. And then I see that this is a diameter that goes through O. And so I know that's going to equal 180. So I can do 180 minus 64. And that gives me 116. And so I know that's what B is, because these B plus that 64 degrees should then equal 180. Then, knowing that, I can also then use that for this piece and take half of this 116 to get this angle here, because this is the endpoints of that inscribed angle, which is going to give me 58 degrees. Okay, and then I know that the angles in a triangle add up to 180, so A plus 58 plus 32 is going to equal 180 degrees. And so if I add those together and then subtract it from 180, then I get A equals 90 degrees. Okay, so we can use the properties about inscribed angles to solve a lot of questions and problems about shapes that are inscribed in circles. Okay, this is kind of a confusing diagram, but I'll try and draw as I go. So the first thing I'm going to do is just label what I know, and then I'll try and answer for A and B, but that's not even going to be my goal to start with. I'm just going to label what I know. So I know that these are the endpoints of the 60-degree angle, so this part right here, which actually ends up being A, is 120 degrees. Okay, I also see that we have this endpoint here and this endpoint here, and I know that this whole piece from those two is 150. So if I take half of it, I'm going to get this angle right here, which is 75 degrees. Okay, and so just by just working through that, I end up with the answers of A is equal to 120 degrees and B is 75. Okay, so if two angles have really basically the same endpoints on the circle, even if their vertexes aren't the same, as long as they're both inscribed angles, the arc they intercept is congruent, which means these are both, they have 70 degrees here, which also means that both of these angles, y is equal to x, and they're both equal to 35 degrees because it's half of that measure. Okay? So then looking at this diagram, we want to find the measure of this angle here. Okay? So the first thing we're going to do is say, okay, this is 38 degrees, so I can double it and get this part right here, which is 76. Oh, but do I really need to do that? No, because I now see that this is an inscribed angle and this is another inscribed angle, and they both have the same endpoints and they have the same intercepted arc right here, which means the measure of angle 2 is the same as the measure of that 38-degree angle. You could also figure that out by finding that this is 76 and then dividing it by 2. Okay, an angle inscribed in a semicircle is a right angle, which means if it has the diameter, that is going to be a right angle right here. And that makes sense because this would be a 180-degree intercepted arc, which means that this angle would be half of that, which is 90. Okay, so then again, I can just use all these parts and pieces to find measures. So the first thing is angle 1 we know is a right angle because there's a diameter right here and that's 180 degrees, so that 90 is half of it. Angle 3 has this intercepted arc right here, which is 40 plus 70. So I need to do 1/2 of 40 plus 70. Okay, and that's going to give me the measure of angle 3. And so the measure of angle 3 is 55 degrees, because 40 plus 70 is 110 divided by 2. Okay, and then we can say the measure of angle 1 is 90. Okay, so now we want to find the measures of all these angles. So the first thing I'm going to do is say, oh, okay, I see this is diameter right here. It's showing me that from angle 4 to angle 2, those two vertexes, and so I know this part right here is 100 because it has to be 180, and this is already 80. I know also this other side is 180, and there's 60 right here, so this part is 120 degrees, and now I can use that and find all of my missing angles. But first, 3 and 1 are both going to be 90 degrees because they both have this diameter you can see that goes through that, so they're both going to be right angles. So I know they're both 90, so the measure of angle 1 is 90 degrees, and the measure of angle 3 is also 90 degrees. Angle 4 has this intercepted arc of 60 plus 80, so I need to do 1/2 of 60 plus 80 to get angle 4, and that is going to give me 70. And I'm just going to keep a list here in order. So that's going to be 70 degrees because that's 140 divided by 2, or 1/2 of 140. And then we have the measure of angle 2, which is going to be 110 degrees because, for the same reason here, we have 120 plus 100, and then we want half of that because that's this intercepted arc right here. I'm trying to show you from this all the way over here. Okay, so 100 plus 120, so that's 220, and half of that is 110, and so that's where measure of angle 2 comes from. Okay, so it's always that 1/2 or double relationship to solve for the missing parts or pieces when you're using intercepted arcs and inscribed angles. Okay, one last property is the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. Okay, so to make sense of that, I'm going to show you on a diagram. So here we go. We have this here, and we know that AB, so this measure of this right here, this intercepted arc, is 64 degrees, okay? Which means that this other side over here is 360 minus 64, which gives us 296. Okay, so now what it's saying is the angle formed here, so I'm actually going to change colors. I don't usually do that, but so I want to show you this angle with the tangent line and that chord. Y is half of 296. So Y is equal to half of 296, which is 148. Okay, and then X, this angle here, is going to be half of 64. So X is going to be 32 degrees. Okay, they always have that 1/2 to double relationship. So everything that we're doing with intercepted arcs and inscribed angles today are always the 1/2 to double relationship. Okay, the last one here is we're gonna work through this. So we know that's 220 degrees, which means this intercepted arc over here is 140, because 140 plus 220 equals 360, and that's what we always need. But then I want to know this angle here that this chord makes with the tangent line, and so I know X is equal to 70, because 70 is half of 140. So again, if nothing else you take from today, remember that it always is that doubled to 1/2 relationship. And again, remember that these notes are all uploaded, color-coded on Classroom as well, and you can just email me if you have questions, and then just complete the 10.4 assignment to go with this. And yes, I will talk to you tomorrow. Have a great rest of your day.